Illionix,
a technology company.
Hello and welcome to DDMP, the Dietary Data Management Platform by Illionix. We are very excited to bring this revolutionary product, and hopefully this video will give you an idea of what it's all about. The DDMP is a system designed to transform traditional dietary intake methods into today's technology standards and bring new and exciting tools for dietary analysis. The system has two major parts. The first part, which is a mobile application which collects user input in an easy, intuitive way that provides the ability to upload the data real-time from anywhere in the world. And the second part, the server-side database which stores this data and contains a series of tools for processing, analyzing, measuring, sorting, and finally producing output material in the form of reports, which can be used by doctors and researchers. Let's begin. I'll show you how simple the mobile application is to use. When you start the app for the first time, you are prompted to log in. This will associate the device with the login name so the database knows who you are. Don't worry, you only gotta do this once. However, there is an option to log in every time, either for added security or in case DDMP is used in a research study at a facility where multiple participants will be using the same device. Next, we select the meal time, such as lunch or dinner, followed by the meal type, such as home-cooked meal, restaurant meal, or store-bought item. Now we can record the food intake. We're going to do a very basic and quickest food entry, which is similar to that of a traditional written food intake diary. Let's start by taking a photo. That was easy. Now let's record an ingredient list. An ingredient list is where we record the individual items that are eaten, as well as the quantity. For this example, we're going to use the voice recognition mode. 1 cup of coffee. Three spoons of sugar. Three cups of milk. You might notice the different colors in the list. When the app performs voice recognition, it uses keywords to try to automatically understand the food amount, what measure, such as a cup, spoon, gallon, or so on, and the ingredient itself. This way, the database can attempt to automatically cross-reference that info with real-world nutritional values. The app has the same nutritional databases on board as the server, in this case the FNDDS and SR25 databases, and it asks the user to refine the search to an exact item in the database. Other databases can easily be integrated into the system. That's it, we're done. Now we just hit upload, and the app will automatically send the data wirelessly to the server, which will be available immediately. We are very excited to bring you the new DDMP laser scanner module. The laser module is a small attachment to an Android smartphone with a lot of potential to change how we look at food intake today. What's so amazing about it is that it is able to capture the food intake in a 3D model, calculate the volume, and even separate the individual food items from one another, providing the first real volume measurement tool, which does not require any other data. It's completely portable, and most importantly, it's accurate. It's a very small device which is built into a protective case for an Android smartphone, and it uses a combination of a line laser module and the built-in phone camera and sensors to capture and calculate points in 3D space. It is powered by the phone and uses the USB protocol to communicate with the device. Alright, let's make a scan. First, the app will have us take a photograph from the top view. This will later be used for image segmentation to separate the individual items from the plate and calculate their volume. And now let's make the actual scan by tilting the phone. The phone does most of the processing of the data on board, and then just like the rest of the entry, wirelessly transfers all the data onto the server, where it's readily available. Let's take a closer look at the data. We're now ready to measure some volume. The first step is to tell the image segmentation tool where the plate is in the image. We do this by drawing one mark through the plate and one through the table. This will help find the plate in 3D space as well as define alignment boundaries for segmenting the individual food items on the plate. We're now looking at the coder interface. We look closer at the tools here in the next section of the video. For now, let's find the volume of the Brussels sprouts. Just like before, we mark the food of interest and then we mark the background. This is where the magic truly happens. The image segmentation tool generates a 2D segment which is relative to the plate, and then it aligns it with the plate in 3D space. It then looks for all the points that fall within that segment in 3D space. Finally, it generates a 3D surface over those points and calculates the volume underneath the surface. There's fundamental difficulty with this method, as you can see from the scan. Because the objects are scanned from top down, they are cut straight down around the perimeter. This makes round food appear more like hills, which is great for things like mashed potatoes, but can be problematic for any food that is round or irregular shaped. We plan to develop a set of coding rules and formulas as well as other tools, which can compensate for the extra volume to make the measurements more accurate. Perhaps the most important part of this project is the server-side database. Just like the other parts, it is a scalable platform and can be used for small studies on small servers, but can also be scaled up to a multi-study, high-volume system in a cloud environment. It is not only a database for storing all the dietary intake data, but it is also a comprehensive set of tools for dietary analysis, which is completely encapsulated into a simple web interface. This allows it to be platform independent and can be accessed by anyone with a computer and basic internet knowledge. Let's look at the database as a study participant. The first thing we need to do is create a login. This will also allow the user to log into the cell phone app. Because the system resides completely on the internet, a participant can access it anytime from a home computer, but also from mobile devices such as a smartphone or a tablet. When a participant logs in for the first time, they are prompted to fill out a questionnaire that a study administrator developed so they can acquire basic knowledge about the participants' dietary habits. We'll show you our innovative questionnaire builder in a bit, but for now let's fill one out. In the future, each study will have the ability to have its own set of questionnaires that a patient can answer. Once again, these can also be filled out from a computer or from a mobile device. The participant can also add a food entry from a computer when a mobile device is not available, or if they simply prefer it. It works in much the same way as it does on the mobile device, but looks slightly different. Now let's log in as an administrator. An administrator has full control over the system. You will notice a toolbar that appears at the top of the screen. It is not available when logged in as a coder or a participant. Let's take a look at some of the features. Let me show you the user management panel available via the Manage Users button. The users are grouped together by their access level on the left side of the screen. There are currently 3 types of users: administrators, which have full control over the system; coders, which are people who are trained to use the coding interface to analyze the participants' intake data; and finally, the participants, which are the study participants providing the data. A new user can be created by pressing the Add User button. Next, let's use the report generation feature. Report generation allows for a quick way to display a large amount of data for easy viewing, storing, and printing or exporting. You can currently sort the data by participant, start date, and end date. In the future, we hope to develop other sorting methods such as meal time and meal type, and when the time comes to develop the tools for storing decoded nutrient data, the ability to generate complex report types with graphs and tables to represent eating trends throughout the study, as well as the ability to track specific nutritional values. The questionnaire builder is an innovative feature which allows study administrators to develop easy-to-use questionnaires very quickly. You can add questions and word answers, but you can also add images to the answer and also what we call the other answer. This lets the participant type in their own answer or be more specific on the answer they gave. Now let's look at some data. The middle section of the screen contains the individual entries sorted by meal time. The left side of the screen contains all the entries sorted by day. This list can be sorted in the ascending or descending order. It's also possible to sort all of the data by meal time or meal type. The individual entries contain all the data uploaded from the device. The ingredient list can be edited here to aid the automatic keywording in the next step. There's also photos and videos as well as GPS coordinates, and when a laser scan is taken, the laser data. The right side of the screen contains any questionnaires that the participant filled out. The coder interface can be accessed by pressing the Decode Entry button. This screen contains the itemized ingredient list broken up individually. The database automatically scans for keywords which identify the measure and the amount of food as well as the food type. It then automatically attempts to narrow down to the closest item available in the nutritional databases. This method cannot be perfect every time, especially with complex foods. This is why a trained coder is needed to aid the system. In the future, the system can be trained over time to become more and more automated as the more data is entered. Also in the future, the right side will automatically generate full nutritional amounts for every item, and when we go to the summary screen, all the data will be added up and visually represented. At this point, the data from this entry will be added to the other entries for the day, and another screen will show the total intake throughout the day. Thank you for watching. The entire Illionix team is very grateful for the opportunity to present this wonderful system to the world, and would like to thank you for being a part of the process.